Hello, this is part 2 of my snake, or our snake project. By the way, I don't know, if you're kind of watching these as they're being posted and I haven't made the next one, then by all means put any suggestions in the comments and I'll try my best to incorporate your ideas. Anyway, as we get to more interesting stages. So in the first video, all we've done is create, kind of recursively, our 10 segmented snake. Or will it have 11? Let me just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, we've got 10 segments. And actually, now that I'm thinking about it, maybe our first segment is created, yes, over the over the head itself. So the reason why that is because we started our loop at 0. So we should start that at 1. Oh, this doesn't feel right. There we go. So now, if we save, we should get 11 segments. So there's the head plus 10 segments. So what am I doing in this video? We want to get the snake moving. So how many have we got? Can I get my mouse out? There we go. Right, we've got the head. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Brilliant. So we've got 11 altogether. And are they evenly spaced? Yes, wonderful. So basically what we want to do is put all of these segments into an array, and then we want to scoop up the tail end segment and then put it on the head in the direction that we want to go. Okay, so first thing, let's put these segments into an array. So we're going to need an array, and they're going to hold these game objects. So by putting these square brackets after the type, we've got ourselves an array, and we'll call that the segments array. Which is the same name as the number of segments. So we'll call that segment n, and then can I just put new game object, and we want how many? We want segment n. Okay, so we've just got to change segment to segment number down here. Right. And then, so all I've done is created an array with a number of game object, what do you call them, compartments, ready to be filled with the number of segments that we instantiate down here. So after we've created and we've moved each segment, we're going to say segments I-1 equals, I've said I-1 because our first segment in the array will be 0. So this is definitely going to create some problems later when I forget this. So segments I-1 equals S. Okay. Now, there's another problem. Because when we instantiate the tail segments, which is similar to a bug we had last time, this game object is getting cloned. So this array of populated game objects is also going to be cloned, which we might want to do for recursive kind of effects later on, but we haven't even got the snake moving yet, or growing or shrinking. So before getting into that, so maybe we want to populate this later on. So we could do that by making each segment a child of our head. Or we could just delete them. No. Or we could delete all the segments created in the new one. Can I do that? Can I just do that? Can I say s dot maybe we should just delete the brain of the segment. I've just thought of another problem. If we shrink the snake, then what if we take the brain away? And indeed, we only want one segment having a brain to kind of control the movement of the snake later on. I didn't think of any of these problems to begin with. Okay, I'm going to bite the bullet. I'm not going to clone this game object. I suppose what will reassure me is if we wanted to create lots of baby snakes recursively or something, we could have a function where we give this snake brain to that segment. So we could do that later on. Okay, so instantiate game object, or do I just say can I say primitive type dot cube? I think that will work. No. What did the error? I didn't actually read the error message. Let's just read this. Cannot be used as type or parameter. Okay. I think we need to use game object to create primitive type cube. That's how we should write that. Okay. What was I actually doing? Oh no. Oh. Oh yeah, I was populating an array, which I'm failing to do. Field initializer. A field initializer cannot reference a non-static field method or property. Snake brain segment n. I think we can do that in generate tail. I think. Let's see. So I think the problem is we can't do that at initialization. We have to do it down here. Let's try it in generate tail. So ready equals false. Segments equals that. Save the script. Can we run? Yes. Okay. Okay. So now we've lost our tail. It's not working for some reason. Let's just pause this and see what's going on. So we have got a load of cubes. Oh, they're being created under the ground. Z. So beforehand, when we cloned our object, it was being placed exactly where the head of the snake was, and then we were just sliding it backwards. So what we want to do is make sure that its position is this game object's position, and then slide it back first. So we want to say s transforms position equals this transform position. Okay, let's just see. Let's just see if that at least gets us back to where we were before. Although, behind the scenes, we have populated an array. Yes, okay. Beautiful. I believe our snake is looking a little bit different now. How many segments have we got? Right, 1. We should have 11. 1, that's the head. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, I think that worked. I jerk slightly over here, but yeah. Right. So we've got our snake, and each time. Oh, we're not populating the array yet. We've got the array ready this time, but now we want to say segments i-1 equals s. Let's just see, and we'll check in the console. It is running at least. We want to check in the console that swig of tea that we've got our array populated. And certainly in this video we want to be able to move the snake. Right, cube. There's the snake's head. I need to make that public really to see it. How do I see this via the console? Collapse? No. Okay. So let's just, at the top here, we'll say public game object segments, meaning when we pause our game in the inspector we should see the cubes populating the public segments array. So pause now, segments, there we go, and we've got 10 items in there beginning from 0. Okay, so we've got our array of segments. Right, so we want to move the snake. So in the previous video we had got this amazing plan where we basically want to decide which direction out of these 5 we go: forward, left, right, up or down. That's 1, 2, 3, 4, 5. 5 directions, and after 10 moves change the direction. So at the moment, let's just see if we can get it moving forward every 2 seconds, let's say. So first we want, let's say, an integer. We'll have a float. Float, we'll call it speed equals 2f. So rate of movement in seconds. Rate of movement in seconds. I'm just going to put in my comments these other things. Almost wrote the word comment. Number of segments. This one is, are we ready to generate our tail? Which is kind of obsolete now that we're not just cloning the head. And this is our array of segments. And this is where we generate the tail. Okay, so in our update function, which is the game loop, we want to, if number of seconds elapsed, move. And at the moment, in this video, we just want it to move forward. Maybe it would be great to turn. It's now 5 o'clock, so maybe another 15 minutes. Okay, so we want to say if current time, how do I get that? Is it time? The time at the beginning of this frame in seconds. Oh, that's helpful. Okay, and it's a float. Okay, brilliant, and we made our variable float. So if time minus timestamp, we'll have to make this variable, so we'll stamp the time, we'll record the time every time we move our snake. So the difference between those, if that's greater than our speed in seconds, then time to move the snake. So we'll say move snake. So let's get that function ready. Void move snake, and we need a timestamp. Firstly, we could do that up here. I don't know which is better. Again, leave a comment if you know. Should I record the time here or actually in the function? Timestamp. I don't know the answer to that question. Maybe I'm thinking only if the function is successful should you make a timestamp. Maybe that's the answer. Timestamp equals time. Okay, so the next update frame, the difference between the time and time will be very small. It won't be greater than our 2 seconds. Have we set that to 2 seconds by default? Yes, we did, I remember. There we go. So it won't move the snake until that's elapsed. Okay, lovely. So we need to make our timestamp. For controlling snake movement in kind of like steps. So that needs to be float, and it's a timestamp equals 0 to begin with. Okay, so which direction? So I've said like 1, 2, 3, 4, 5. In a sense, now we can do one of two things, or one of many things. We could actually rotate our head segment and move it forward, and then we've got to move all the other ones forward. But we don't actually want to do that. We want to suck off the oldest kind of segment in our array and place it in one of these 5 directions ahead of the snake. Okay, so we've got to keep a track. The brain will have to keep a track of which segment needs to move. So let's write that here. Int which segment equals 0 to begin with, and after we've created the segments, we're going to say which segment equals we could say we'll say segments length. So that's the length of the array, but it's got to be -1 because we started counting at 0. So which was the last segment in the array. So now all we have to do, if we wanted a longer snake, we could just change this single number, and then the rest of our code will dynamically work around that. Segment number here will change, segment number here will change, segment here, and this array length will change as well. So we're not having to change the code in lots of different places to make one change. That will all kind of work together. I'm not saying this is good this is this is how it should be done, I think. So I'm saying that's better than having to change your code in lots of places, which is good practice. Okay, what's the time? 5 past now, so 10 more minutes. We're so close, aren't we? So a move snake, we want to say, oh, I've just got a message. We want to say, maybe, is this my snake communicating to me? No. Right, we want to say, move our which segment in chosen direction. So let's say segments, which segment position, transform position equals. Now I wonder if we can do this in one leap. Can we say we want to kind of say we don't want to say the first segment in the array, because that's the one behind the head. We need to put the head in the array as well. Right, let's put the head in the array. And that's got to be 0, because that's at the head of the array. Okay, so maybe can I just say the first segment that we've created is going to be in position 1. But first we want to say, well, this is kind of recursive. Am I allowed to do this? It's like a snake eating its own tail. We're going to say segments 0 equals this game object. Okay, how interesting. And then, oh my god, we're going to say this segment equals, we need to keep track of the front of the snake as well, I think. Yeah, I'm just thinking there's different ways to use the array. We could like shift them all along. We could do that. We'll do it this way. We'll carry on this way. Which segment? We're going to say int head segment equals 0. So every time we move the snake, we need to change that. So the head of the snake is going to be the which segment number. So after we've moved it, we can say head segment equals which segment. And then we need to say which segment equals, so if it's going to be the last segment, if it's going to be segment 9, then it's going to be segment 8, so it's going to be -1. Equals which segment -1. But then if which segment equals -1, then which segment equals So if we've gone beneath the first segment, then we want to go to the last segment in the array. So we want to say segments length -1, because we started counting at 0. I think all that's right. So basically we're answering the question, which is our head segment and which is our tail. Okay, we're doing a lot of programming without testing these steps. So we've taken care of the complicated stuff after we've moved the segment, but we want to say our position equals the head of the snake's position and then move it forward. We were trying to do that in one step. So we're going to say segments head segment transform position plus, no, let's not do it in one step, in two steps. So we've put it in the head position. So let's say that. So position what's going on here? Position end segment on top of head. Next, move new head in chosen direction. And at the moment we just want to go forward. So segment, it's not yet the head segment, we swap those later on, so it's still the which segment. Transform, translate, have I typed something wrong? Oh, segments, it's an array. Translate. So now we're going to say we want to be, okay, we want to use this segment's orientation. So we're going to say segments, which segment dot transform dot forward, so the direction it's pointing, in other words, times 1. I think, my God, I think we've got there. So that should happen every 2 seconds. Okay, so let's run. And hopefully the time, oh no, there's a problem. Into a bool. If which, oh. If you've got the timing right, it'll only happen every 2 seconds. So it'll give me a chance to go and find our snake and see if it's moving. Okay. There is some kind of movement happening. And so we haven't got the positioning right. So we've said move it 1, where we need to move it 1.1 1 times 1.15. Oh, we've got an array index is out of range. Oh my goodness. So I've got some kind of problem. It's not a snake at the moment, it's a worm. It's burrowed underneath. Okay. Oh. And we've left the segment up there. My goodness. So segments I equals S. Oh yes, of course. So what's happening there is our array starts counting at 0, whereas if we've got to the segment number, then we've gone one beyond the end of the array. But we did have 11 segments. So that's still got to be minus 1. Oh, we've got to put one more segment in so that we can hold our head. So that still needs to be minus 1, so we don't want to go to the end of the array. Maybe that wants to be there. That's now safe. So we've counted all the correct number of segments. Do we just want to add a sneaky one here? Will that work? I think that will work. Okay, right. Now we want to make sure that our snake starts higher in the air. So we'll make it 32. And when we moved, we wanted to move times 1.5. So we'll call that the spread. The spread. Again, I was just about to change that in 2 places. Whenever you want to change something in 2 places, time to make a new variable. So we'll call that public, or I'll make it private at the moment. Float spread equals that. How spread are the segments? And we need to use that in the movement algorithm as well. So when we translate it times the spread, there we go. Right, let's see if that's shuffling along. We also might want to increase the speed of our snake so we can kind of see it moving more quickly. Right, it's not even moving at all now because of all that messing around with the arrays. I've gone completely wrong. Object reference not set to an instance of an object. So segments, which segment? So that starts with 0. So we're going to have 11 segments. Let's track this down here. We're going to have 11 segments. So we're creating 11 places. Segment 0 equals this game object segment. I hope that's working already. Then we want to go around 10 times. So 1 to 10. That's going to be 10 times. Segment I equals S. Which segment is the last segment in the array? That is going to be segment 11. I think all that's fine. What we could do is pause it and make sure that our array has been populated correctly. I'm not getting an error this time. Okay, our snake is moving in the correct way. Is that correct? Yeah, I think that's correct. I was just thinking then, maybe I want it to, I don't know, the snake's kind of tail to stay as it kind of like grows. I think you'll get more of that effect as it steers around. Okay, so we've got our snake moving. Oh, I've let this video go on a bit long. I apologise if I was just staring at the camera trying to work out basic problems for too long. So I've got it moving. I want it changing direction. So we need two variables here. We need a variable for which direction. So we'll call this, this is an integer, I guess. We could have integer which d, and we can say 1. I'll say 1 equals forward, and so on. So if we remember our diagram, this will be direction 1, and then we could say left is 2, right is 3, up is 4, and 5 is down. And we're going to change direction after 10 moves, so we need another variable to keep track of how many moves. So we'll call that int how many, or step count we'll call it, step count equals 0. From the beginning we haven't taken any steps, and so at the end of moving our snake, we'll say step count plus plus. So we'll say snake, although it steps, it hasn't really got feet, so it can't really step around. But snake has taken a snake has taken a step. I'll leave that sibilance in there. Snake has taken a step. And we're going to change direction. So we move the step, we move the snake, and in our update loop, we can say, actually, we want to do that inside this. I was going to do it outside of this question, but if we had taken 10 steps, then every update loop, it would possibly change the direction, which we don't want to do. We only have to do it once after it's taken those 10 steps. Then move the snake again, and it'll be reset. So we want to say check steps, or check direction. Maybe you could ask a question here. We could say if step count equals 10, then go to check direction. So we better write that function void check direction and we'll say step count equals 0. So we start the counter again, so every 10 times this will happen, or only every 10 times. Again, we could place that in a variable, so we could change the amount it changes direction. And then we could say something like int which what do we call it? Which d? int which d equals random range, turns a random float number between and minimum inclusive and max inclusive. Okay, between 1 and 5. I think that's inclusive. And I've just said int at the start in brackets to change that resultant float to an integer. Could I just floor it? I might have to floor that. Math floor. Oh, sorry, is it math f? Yeah, math function floor. Will it ever get to 5? Do I have to go up to 6? 4.9? Will that be fairer? 4.9? I mean 5.9? Again, comment mathematicians to help me out there. So we've got a new direction, and now we could do this in one of two ways. In our move snake, here, move the head in the chosen direction. We're just translating it forward times the spread. So we could just, the easiest way might be to move it up, or minus up to go down, and then right or minus right to go left, which would be the easiest way. Or I kind of had it in my head that I wanted to rotate the head and then move it after it. What would be best? Well, if we colour it later on, if we texture it later on, and we just move it in the simple method, then we won't have like the snout of the snake in the correct direction. Let's do it the simple way first. That's a good coding rule. And then if we need to update it, we will. So we want to say if which direction equals 1, then do that. Else, if which direction equals 2, then translate it this way. So 2, I believe, was left, 1 was forwards, 2 will be left. So that will be right times minus spread. Three will be right times spread. 4 will be up. Let's just check that. 4 will be up. So I just write up times spread. And then if the direction equals 5, then we're going to go down, which is up times minus spread. Okay, I could have used switch there, but for simplicity, that should work. Okay, save this script. I really need to stop this video now. I'm going to make my snake move a lot quicker. So we're going to say, where's speed? Speed, we'll say 1, so it moves every second. And every 10 steps, we should get a change of direction. No, what have I done? Oh, that can't be a float, or do I have to put F in there? Cannot implicitly convert float to int. An explicit conversion exists. Is that right? Okay, I think we've got it working. Right, he's moving. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So either he's randomly chosen to go forward, or my randomizing didn't really work. I've lost count of how many he's done this time. Okay, it's beginning to burrow. We're going to lose him. If he's chosen to go this way, sorry, it's a she, it's a female snake, we won't be able to see it anymore. So off she goes. Oh, it's come out the other side. That's not a good sign. That suggests it's always choosing to go forwards after 10 steps. So 2 possible places this bug is going wrong. It's not counting the step count in the correct way. Actually 3 places it's going wrong. Second, it's not choosing a random number. And 3, I'm not translating it correctly. Okay, so I think it's this random business. Let's take off math floor for a second. The problem might be because I put 5.1 in there. Let's just go to 5, range 1 to 5, integer, which direction? Okay, and let's try running it there. I don't know whether now to stop the tutorial, this must be a long video. Either stop the tutorial? It's not a tutorial, it's kind of a creative coding adventure. Here, or even if the bug persists, or whether to carry on and try and debug in the video, but that might mean another hour or something. Okay, how many steps? I think it had kind of hit this edge last time. So again, it's... Oh, this is quite... I'm Jim Morrison. I'm Jim Morrison riding the snake. Oh. It's gone. It's worming its way. So it looks like it's definitely not changing direction. So let's... I won't debug completely, but let's just add some debug lines. Firstly, where's the update? If I'm checking the direction, let's just say debug log. I should be changing direction ... exclamation mark. So if we manage to get in there, it should be changing direction. Check direction, step count equals 0 again. Which direction equals that? So after we've chosen a new direction, we can say new D equals space which D. So we can have a look in the console which direction we should be going in, 1 to 5. And then move snake if which direction is 1, 2, 3, 4, 5, and we've definitely changed all of those, so that should be correct. It all looks correct, so it'll be very interesting to see what our debug logs will tell us. So firstly, they're not speaking to us. New direction equals 3. Already. New direction equals 1, 3, 2, 1, 3, 1, 3, 1, 3, 2, 1, 2, 4, 1, 2, 3, 4. So firstly, it's changing direction every single step. which you should not be doing. Secondly, it's not hitting direction 5. So our range needs to go up to 6, clearly. Step count equals 0. Step count plus plus. In our update function, let's see. It moves the snake. If step count equals 10, check direction. Check direction sets step count to 0. So that should not happen every single time. This, what on earth is going on? That's not getting reset properly. Step count, if step count equals 10. Oh, because I've got a debug in there, only check the direction if the step count is 10. But still, we weren't changing direction. Maybe I need to organize these a bit more. I'm sure I've only got one statement in there. This might show my ignorance of some C# conventions. I don't know. And I've also changed a few things, so I don't know which one of them has solved the problem necessarily. Let's just save the script. What was my console saying? My console was saying new direction equals 2 Unity engine debug log object. Oh, and I never got a... Where did the get... I never got a... We should change direction. Oh, because it was being reset to 0 every single time. Right. Okay. How long has this video been? Maybe 50 minutes or something. Okay. Our snake is moving in a straight line, as expected. How many steps has it taken? About 8, 9, 10, 11, 12, something like that. New direction equals 1. Fair enough. So it should be going in a straight line again. New direction equals 2. It should now be going left, which it definitely is not doing. New direction equals 3. So that means it should be going left. And it's definitely still going forward. So, I thought that was an optical illusion. I thought it changed direction somehow. Oh dear, so there's something wrong with this part of the code. It looks like I am debugging now. If which direction equals 1, then segments transform translate which direction transform forward times spread. Else, if which direction equals 2, transform right times minus spread. But it's always going forwards. Our which D was definitely changing. Oh. That should just be which D. So it looks like maybe I was creating a new temporary variable, and maybe that was interrupting which D. Okay, that might be our bug. Because I was completely stumped. Okay, it is running, so I haven't changed anything too serious there. Okay, we're moving forward, as we should be. And new direction equals 1. Meaning it's going to choose to move forward again. And any second now we should have a new direction. 3. Ah! It's working! Okay. And that's looking like snake. Oh, that's cool. And 4, yep, it's going upwards. Oh, brilliant. So there, I'm going to leave the second video there. We've got 3D snake moving around, which is kind of cool now. Off he goes. It's quite interesting. We've got some life because we don't know which way he's going to go. So we've introduced that unpredictability into our code, into our simulation, which means it's kind of fascinating to watch. Right, we definitely need him moving a lot quicker. Okay, we need some bounds for where he's allowed to go and things like that. Oh, and he just went back on himself. Which should be impossible. Ah, I know why that is. Can you guess? Find out next time. So hopefully that was a little bit fun. Apologies for the bugs, although that's kind of what I want in these kind of videos, so that we work through them, learning new things. Yeah, he's definitely going back on himself. Okay, thank you very much. See you maybe in the next video. Goodbye.